Hello guys, welcome back to my YouTube channel. Today I will be discussing about a tool called Jaeles. This tool is similar to Project Discovery's Nuclear tool. If you are aware of Nuclear tool, then it is pretty much similar, but there is one additional feature in Jaeles, that is it can be integrated with Bob Suite. So this tool is like a tool which can help you to create your own scanner. For example, if you want to create an access scanner, then you can just create a signature file for that, and then you can pass on that signature file to the tool, and then it will scan for access vulnerability and it will give you the results. So let's go to our browser, and if we go to the official repository of Jaeles project on GitHub, then we can find this tool. For example, go to GitHub and search Jaeles in all GitHub. Then once you search, you'll get different repositories. This is the official one. Go to this repository. So this tool is created by Jesse. You can follow him on Twitter. So let's see how this tool works. This is the architecture of tool. You can read more about it. Then how to install this tool. So there are different ways to install this. You can either download the pre-compiled version from here. Just go to this link and download the Linux AMD64.zip file. Once you download it, extract it, and then move that file to the bin folder of your system. That is usr/local/bin directory, and it will be installed. Or you can also use this go module command, which will install the tool into your system. For this, you need Golang greater than 1.13 version. If you have not installed Golang, then I'll share the commands to install Golang in the description of this video. So I'll show you which all commands you need to run for installing Golang. For installing Golang, this is actually a script which I use when I move from one VPS system to another VPS. I usually don't install each and every tool one by one. I'll directly install this. I'll use this script and I'll install all the necessary tools at one go. So these are the tools which I use for my bug bounty hunting. For installing Golang, you have to type this command, which will download the .tar.gz file in your system with the help of wget. Then you have to extract it with this command. Once it is extracted, you have to move it to local usr/local directory with this. Once you have moved, you have to just use this command to set the environment variable, that is go root and go path. And then these three export commands, once you have typed, you have to update your bash profile. And once you have updated till this point, your Golang or Go tool will be installed and you will be ready to use Go. Once you have installed Go, go to your terminal and check, type Go, and you should see all these flags for Golang. That means you have installed the tool, you have installed Golang. So once you have installed this, now we need to install Jaeles. So go back to this repository, copy this command, and paste it into the terminal. Once you paste this, and if you don't get any error, then you are good to go and you can use this tool. If you get any error, you can directly download the precompiled version, that is the binary file from here, and then place it into the user/local/bin directory. So I have already installed this tool, so I'll cancel this installation. And if I type Jaeles -h, so it will show me the different commands which I can use. That means this tool is installed properly in my system. So so now we will see how we can use this tool. So there are three different modules. First one is scan. This is basically used for scanning subdomains, IP addresses, and the sorry, you can scan subdomain IP addresses and URLs with the help of scan command. And with the help of server, you can integrate Jails with Burp Suite. And with the help of report module, you can you can generate a report of the scan which you have performed. So we will see each option. So now there are different types of testing methodologies which we can follow while using Jail Scanner. So if suppose you want to test if you have like around hundred or thousands of subdomains, or let's say you have hundred or thousands of IP addresses in a text file, then you can pass that text file to this tool and you will have the CVE signatures created. That signatures will be scanned for all those IP addresses. So this way you can scan multiple IP addresses or host names at one go. So I'll show you how to do that. And then you can, this is also same. In this case, we will pass subdomains. Here we passed IP addresses. And then after that, there is one more methodology where you can collect URLs from Wayback Archive.org or get all URL tool. This GAU you can download from GitHub. Just go to Google and search GAU. This tool actually it will collect URL from different sources like archive, webback machine. So from here it will collect, and there are many other sources from Alien Vault, Open Source Intelligence, Open Threat Exchange. From there, it will collect the URLs and it will give you a list of URLs. So for installing this also you need Golang. Once you have Golang, the command for installation is you can copy this Go module command. It will install this tool into your system. And the usage is pretty much simple. Just type GAU and the domain name. It will give you all the URLs for that domain. I'll show you like how we can use it. So let's go back to our file, that is text file. So till this point, we can use scan module. And then if suppose this will be an unauthenticated testing because this URLs which you have collected from archive.org or let's say Wayback Machine, those for that you will need session, right? So we can't pass the session directly to the Jails tool. So I'll tell you how we can do that. So the next step is like the next fourth mod methodology is when we integrate this tool with our Burp Suite and perform the testing on authenticated endpoints. That means you can first log into the web application and then you can just crawl the whole web application or you can spider the web application. You can collect endpoints and then you can start the server and then you can scan all those URLs. We will see each and every point in detail. And then once you are done with your scan, you can just generate a report of all the vulnerabilities which were found. And at the end, you can also use this tool as directory brute forcing, but I won't suggest that because we already have great tools for that purpose. The tools like FF, UF, and diff search they are great tool and you can make use of them. So let's check the demo. For example, the first one, if I have a list of IP addresses, so let's say Right now, I don't have IP addresses, so we will, for testing purpose, we will go to this hurricane dot bgp.he.net. That is, it will give you the IP address info of a particular domain or an organization. It will also give you ASN numbers. It will also give you CIDR range. So this website is very helpful for getting that information. Go, yeah, just type hackerone.com and click on search. Once you search, go to this tab, IP info. Go to this tab. This is the CIDR range and this is the ASN number. So let's suppose I will like copy all the, I want to scan all the those IPs included in this CIDR. So there is one another website that is magic-cookie.co.uk. Go to that site and type the CIDR range, that is 104.16.96.0. Yeah, it is correct. Just go to that site and just click on list addresses. Once you click list addresses, you can copy all these IP addresses into a text file. I won't copy all of them. I'll just copy a few and I'll paste it into a text file. So I'll create a text file called ip.txt. I'll paste it here and I'll save it. So this is the file. The IP address should be in new line. Each IP address should be in new line. Once we have the IP address, this tool, we cannot directly run Jaeles on this list of IP because right now the IP address does not have the protocols with them. They're like HTTP or HTTPS. So we have to run this tool on live websites. Live, I mean that gives us response on port 80 or 443. That is HTTP and HTTPS. So for that reason, I will just use another tool called Httpx. You can install this Httpx from GitHub. You can go to the repo and you can check how to install it. And then, like I want to save the results into another file called probed.ip.txt. So I'll give this p-a command for that, and it will just print on screen and it will also paste it into the file called probed.ip.txt. So if you check now, we have IP addresses with along with the protocols. So now we are ready to scan all these IP addresses. Just type Jaeles scan, then -c is for concurrency. If you don't remember commands, you can always type -h and you can see what all flags are available in this scan module. Just hit enter, and as you can see, uh, there are different flags. You can read more about it, but for this video, I'll tell you we can use basic command, that is Jaeles scan -c. This is concurrency, and then -s is for signature. You have to give path of the signature file and then the list of URLs. That is sufficient. And if you want to save the output into a directory, then you have to pass -o, that is this, like this, -o slash the path to the directory of the output. So let's use this command, Jaeles scan -c for concurrency, -s for signatures. So I have already, let's list all the directories in present working directory. So I have already cloned this Jaeles signature repository. You can do that. You have to go to, again, you have to go to this GitHub, and then you have to search here Jaeles, search in all GitHub, then you will find the official directory or default signature for jail scanner, which is created by Jesse. So go to that repository and just clone, or you can just download this as a zip file, or you can just clone like this, git clone, and then copy the URL and paste it over here and just hit enter. Okay, sorry, there is a there is some mistake. You can type this command. No, okay, but I don't want to. Okay, sorry. Actually, the command is correct, but as I already have this jail signature directory, that's why it gives me error. But if you do that, this directory, this repository will be cloned, and you can just browse that directory, and you can see there are different folders. You have to go to, let's suppose, if you want to go to CVEs, then if we do ls, we will see different signatures for different CVE IDs. So, so I'll show you the signatures. So for now, for our example, let's suppose we want to scan all those IP addresses for this particular vulnerability, that is CVE 2020-5902. And this probe IP.txt file in the current directory, that's why it gives error. So I'll move back to the home directory by ///, and then I'll hit enter. So now I didn't get any output because the definitely the vulnerability does not exist, and that's why I didn't get the output. If you want to check, we can give -v is for verbose. We can give this flag, and we can check what all requests this tool will send to the server, the remote servers. So as you can see, for each IP address, it has sent a bunch of requests, and this is our payload. We have just passed the list of IP addresses, but it has added this path by default to the it has appended to the IP addresses. So what happens is, like, when you pass the IP addresses and whichever signature you select, it will take the payload from the signature, and it will append it to the host name or the IP addresses, and it will check in the response if the response it will actually grab the response, and it will check if it is vulnerable or not. So let's go to understand this in detail. We will check the signature file, that is f5 big IP.yaml file. So as you can see on the screen, let's go to GitHub repository and check there. So if I want to check the signature file for f5, go to CVs, and then check, open this file f5 big IP RC. Okay, so till this point, this is, you can say, is informational. It is not required. This is just for our information. The actual signature starts from here. That is param root. It will take base URL. In our case, base URL was https:// the IP address. That was the base URL which it got from the -u flag. For each IP address, what it does, it generates a request with a method get, and it won't redirect because we have said, like, do not redirect. And then it will append this path to all those IP addresses, what we have already seen. See, it just takes the IP address and it appends this path to each IP address. And it adds some headers, that is user agent, And the detection mechanism says like if the status code equals to 200, and it will search for a regex pattern that is root colon x colon 00, that is it will this is the content of etc slash passwd file, because as you can see in the payload we are trying to read etc passwd file with this parameter file name. So if this regex matches in the response, that means it is vulnerable. If this does not matches in the response, that means it's not vulnerable. Hence, our output was blank because all those IPs were not vulnerable to this particular CVE ID. So if you scroll down, there is one more method. Actually, it sends two different GET requests. One is to this path, and the another one is to this path. That is, there is a parameter called command equals to list all auth user admin. And then again, it sends the headers, and the detection mechanism is same. It searches for a 200 response, and this time it is not searching for a regex, but it's searching for a simple string that is in body, in the response body. If it finds output and means plus, this both words are there in the response, that means it is vulnerable. If these words are not there in the response, that means it is not vulnerable. So, how to create this signature? So now you must have got idea like how this scanner works. So that's why I said with this tool you can create your own scanner, but for that purpose you have to work on it. You have to create the signatures. So I will give you a short demo of that, like how can we create those signature files. So let's suppose there is a new CVE. We can go to exploit DB. There we can check for new CV IDs, because probably if there is a new CVID, there are more chances that you will find it on bug bounty platforms like bug bounty programs. So go to exploit DB and just search for any web CV, that is web app CV. So let's suppose there is a SQL injection error base. So you have to think, because if there is a auth bypass, you can't create the signature for auth bypass. It all depends on what all payloads you send. So we will take LFI for example. If you want to hunt for LFI, so there is a CS card 1.3.3 web app where there is a this LFI vulnerability. So as you can see in the POC, this the path for the vulnerable parameter is classes PHP mailer class.ch PHP mailer.php, and the parameter is classes underscore dir equals to evil script. Uh, Basically, this is the uh, vulnerable parameter where you can inject the payload. So you will get an idea that this is the path and this is the parameter. So what you can do is you can create your own signature with this particular path. So whenever you pass a list of IP address or a list of domain, it will just append this path to all the domains or IP addresses, and it will check each and every response, and it will try to find the match in the response. That is, in this case, we should search for same root word in the response. That is a reject search, what we did before, because we are trying to read etc passwd content, right? So you can copy paste this detection code and you can place it into your signature. So this is just an example. You will have to think, if you want to find unique bugs, then definitely you will have to work on it. You will have to create your own signature. So this was one example for creating CVID signature. If you go to the Jaeles directory and try to check all the signatures for CVID, you will understand how this tool works. So you can go and check the repository, official repository for this purpose. Now we can just check the other point, that is, now we know how to scan for CVs on IP addresses. So same goes for subdomains. If uh, if suppose I'll use another tool called Asset Finder. Asset Finder, then I'll give hackerone.com. This Asset Finder will list all the subdomains of hackerone.com. Once I hit enter, it will list the domains. Let's subdomains, sorry. So let's wait. Okay, it has found this many subdomains. Now again we have to pass the list of subdomains along with the protocols like HTTP or HTTPS. So for that reason, I have to again pipe this with another tool called Httpx, and then I have to save it into another file called, let's say, subs.txt. And then when I hit enter, it will generate a new file called subs.txt, and it will append HTTP or HTTPS in each, in each subdomains. You need to unlock your iPhone first. Okay, so now I have subs.txt. Sorry, subs.txt. So if I want to run a scan on this, again I'll use the same, but instead of the text file, this time I will pass subs.txt and -v to see the verbose messages. So here in summary, we can see signature loaded is 2, and the input there are 10 subdomains, and signature 2 because there were 2 GET requests, that's why it is saying 2. So again it sent all the requests, but it didn't find anything because that was not, definitely that was not vulnerable. uh, it was not able to find the big IP vulnerable machine, or the that's why it was not able to detect it. If it is able to detect it, it will be in a different color, and it will generate a new folder with this path, like out directory, and there will be different files, but you can cat this jail summary.txt, which will include all the URLs which are vulnerable. Right now, I won't have this out directory. If I try to go to cat directory, there is no, sorry, out directory, there is no directory because definitely it was not vulnerable. That's why. So now you know how to scan a list of subdomains. So now this is also pretty much same. You have to just collect the URLs, and then you have to probe them. Like you have to use HTTP or HTTPX if it is not there, and then you have to pass it to the tool, and it will scan for those. It will scan for vulnerabilities. But this time you won't pass CVIDs because these CVIDs will be definitely on the root path or on this subdomain. It won't be in a parameter, right? So you have to scan. If you have a list of URLs, you can fudge different vulnerabilities. Like for example, if I go to GitHub and official jail signature repository, there is one directory called fuzz. And then if you, let's suppose if you want to hunt for LFI, or let's suppose CRLF. So this is one signature for CRLF, and if you have a list of URL, what it does is, so our signature starts from here. This is again not needed, it is just for our information. Like when we get the output of this scan, it will display the name of the vulnerability and the risk and all those things, but we don't need that. The actual signature starts from here. So it has defined variables and prefix. In prefix, it has defined the characters that is percentage 0D, percentage 0A, because this is our payload in CRLF attack, injection attack. And then it has one more payload. So I have a different signature which I use. That is, I'll show you that. And then the payload will be like it will add a unique word, and then it will just paste this payload from here into this variable, and then it will again add some random words, and then in the response while detecting it will check all these things, like this will search for this word first, and if the string does not match, so if you see this two exclamation, that means and does not match this response. That means in between there should be something, that is a new line, correct? Because in CRLF attack, when we pass percentage 0D 0A, it will move to the new line, correct? So that's why if the response has this word, that means it is false positive. So it totally depends on your thinking, the way you create the signature. If you create a perfect signature, then you will never get a false positive alert. If the signature is not appropriately created, then you will definitely get a lot of false positives. So, like I have heard from many of you, like you say that Jaeles gives many false positives. So this is the reason you can't depend on the default signature. So I'll show you the signature which I have created for my testing purposes. So if I go to, let's say, okay, this is my repository, my signatures. So for CRLF, what I did is like you can copy different payloads. That is, you if you don't know the payloads, just go to payload all things, and there you have to go to that particular vulnerability directory, that is CRLF injection, and just go to this text file. You can copy paste all these payloads into your signature, and then in request generator, means this is the payload, and when we are saying to Jaeles that generate request of this type, means this query will append the parameter query parameters. This is nothing but query parameters. So in what all query parameter, wherever we see query parameter, that is in get URL or post body, sorry, there is a different method for post, but in this case it will just check get URLs, and if it finds any parameter it will append all these payloads one by one. For example, example.com question mark ID equals to something one. So it will replace one with each payload, and it will check if there is a CRLF injection. And in reject in detection, I have given that do a reject search, and in response header check for set cookie, because see, if you inject percentage 0D percentage 0A set cookie colon CRLF is equals to injection, that means this will be appended into the response header into the new line. So the reject search is according to that. It will check in response header if this set cookie is successfully set or not. Means the our cookie, that is CRLF equals to injection, this cookie is set or not. So this way you can create, and the generator also have path. Path means I don't have to only inject this payload into the parameters, but also into the path. Path, for example, this master is the path, right? So it will inject percentage 0D 0A here. It will also inject in the another path, that is blob path. So how many paths are available in the URL? So that many times it will inject the payload. So that is the use of path. And again, this query is different with this because it will keep the original data and it will append the payload. But here it will remove the original and it will directly replace it with the payload. So that is the difference. So this way you can create your own signatures and you can scan for different vulnerabilities. This was for CRLF, so I have created a bunch of different signatures. I would ask you to create your own for accesses. Let's suppose we'll see for accesses. We can just inject this double quote colon then double quote and then single quote and then angle brackets and inject table and then quote close. If in response it is means we if it is printing same like this, if it is not encoding it, that is if it's not output encoding, then that means it is vulnerable to accesses. So again we have for generating the request, it will fuzz this payload in each query parameter. It will keep the original one, and in after the original parameter value it will append this payload. And once it adds this payload in the response, it will check for status code. If it is 200 and the string search is it is printing as it is like what we have injected, that means it is vulnerable to accesses. So this way, you don't have to test each and every URL and each and every parameter. You can directly inject you can basically you can fuzz this payload in everywhere, like all the query parameters. So this is for probing for accesses vulnerability. So same way I have created a bunch of YAML files, that is the signature files for LFI Unix, for LFI Windows. I have already told you you can take help from payload all things. You already have all the payloads. You can add your filter bypass payloads. You can add your WAF bypass payload into the signature. It is fine. As long as your detection mechanism is correct, it will definitely detect and it will give you true positive. So for LFI, I have uh, all these payloads. I have collected it from different sources. And again, I will pass this payload to each query parameter and in each path, because LFI can exist in query parameter as well as in path. So this video is basically, I assume you already know about different vulnerabilities. I am not covering the basics of what types of vulnerability exist in a web application. So if you don't know about LFI or XSS, please go and read about it. And again, in detection, if this is successful, that means we are able to read etc passwd file. Then in response, it will check for this particular response, that is root, and it is a reject search. And if it matches, that means it will give you true positive. So now let's test on lab. Like I have logged into the Portswigger Academy. So now let's test our signatures which we have created on Portswigger Labs. So for example, let's see template injection labs. Template injection. Okay. So I'll open the first lab. Okay. And as we know, there will be a template injection vulnerability on this particular lab. So let's wait, and here I'll show you how we can integrate it with Pub Suite. So first of all, for that reason, uh, let's say we type this command jaeles-h. So as I told you, we have different modules: scan, server, and report. We have already seen scan module. Now let's check server and report module. So for that, there is a command jaeles server. -s is for the signature which we want to load into our jaeles server, you can say. So once we load the signature, then the server will be powered on, you can say, and then we can just scan through Bob Suite. I'll tell you how we can do that. So for this, you need to enter the command as said, like jaeles server hyphen s, then I want to scan for SSTI, right? So server-side template injection. So I'll give path to the signature, that is I have my own signatures in this directory, and then ssti.yaml is the file name for template injection. Let's suppose if you don't want to scan a single file, that is a single vulnerability, and you want to scan all the vulnerabilities that are that all the signatures that are present in this directory, that is my signature, that has CRLF, DOM accesses, then host header injection, then LFI, open redirect, all these vulnerabilities. So in that case, I will directly start the server here itself, or you can give star mark over here as given here, like dot star, or you can directly on the server like this, and hyphen v also you can give. I guess hyphen v will work. Yeah. So in hyphen v, it will show you the verbose messages whenever it detects the vulnerability. So now, as you can see, all those signatures have been loaded because I have given the path and not a single file. So I'll cancel this and I'll again start the server because I just want to test for SSTI, and then hyphen v. So now we have started our Jaeles server. We got a URL. Just open this URL in browser. Let's suppose I go to this URL. Sorry, it was not copied. Copy link address. So I am right now, I'm actually already logged in to this. But if you for first time, if you try to access this page, you will be asked for credentials. So that credentials are present in a file called. You have to cat this file, particular file. It has the credentials. So this is the password, this is the secret, and this is the username. So this is my username and this is the password which I need to log into this portal, Jaeles portal. Then you can go to scan. You can see the scan results if it is detected. So let's now we need to integrate it with Burp Suite. For that reason, go to Burp Suite, then go to Extender. You need to install a Jaeles extender, Jaeles plugin. Sorry. So for that reason, you will need two things. You need to give a Jython path, that is yeah, here in Python environment, you need to give the path to Jython standalone.jar file, and then in extension, you need to add the Python file. So this file is available on GitHub repository. If you go to Jaeles project, then if you scroll down, then there is burp integration somewhere. Also, I missed to say that you can pull the Docker image for this Jaeles project if you have Docker installed. Scroll down and you can see some demo videos. And if you scroll down, then you can see the sample report, how it generates like after we scan. Then this is the burp integration. This will tell you how we integrate, but I'm going to show you the same thing. So first you need to download the plugin from here, and once you go to the URL, there will be a Python script file. You can say you have to just download this file, and then you have to import it here. So for this, I'll select Python and select the file that I have downloaded it, that I have renamed it to jaeles.py, and then click on next, and then this will install the extension. So it has been successfully installed. Now go to this, there will be one tab. This tab will be added once you install this. Just reload and test the connection. So it is working fine. It doesn't give any error, so it's working fine. So now what we need to do is normal, as I told you before, you can collect or you can spider the whole web application if you want to test multiple URLs. All these URLs will be authenticated, right? That's why I said that integrating with burp suite for authenticated scanning. So now I have collected all the URLs, let's suppose. So just I'll show you for one URL, that is we will test for this particular lab, right? So go to this SSTI lab, then click any image. Let's find the parameter which might be vulnerable to SSTI. Okay, so here it says, unfortunately, this product is out of stock, and URL you can see the message. So if so, there is a bug in this tool. I'll tell you what is that bug. So let's suppose this is the URL. So I'll go to burp. I'll need to first intercept this all the requests. So I'll on the proxy listener, and then I'll refresh this page, and it will show me here in burp suite. Go to burp, cancel this. Actually, already it has been imported, right? Yeah, it's there. So I have just refreshed the page, and I can see the messages, like the URLs. So I'll go to proxy history and then see this was the URL, right? So now the bug is, like, if you directly send this endpoint, the normal way to scan this URL is right click and send request to Jaeles endpoint, and it will start scanning this particular endpoint. And what it will do is, like, the signature which we have created in all those places, it will fuzz the payload which we have in that signature. For example, if we say fuzz the payload in query parameters, it will only fuzz in query. If we say fuzz the payloads in path, then it will inject the payload over here before message parameter. If we say inject the payload in headers, then it will inject SSTI payloads in headers as well. So this tool is very helpful. It can do, like, sky is the limit for this tool. You can do anything, whatever you want, you can do. Like, you can fuzz any part of the request, like cookie. If you want to try SQL injection in cookie, then just fuzz the SQL payloads everywhere, in every part of the request. If you'll check my other videos, I found one SSTI when I first the headers, and the tool was able to detect the SSTI in CSRF header. So many have asked, like, how did you recognize that, or how did you guess that CSRF token will be vulnerable to SSTI? Definitely, I didn't guess. Actually, I first all the headers, and that's why I was able to find that SSTI. So now let's suppose this is the parameter. I have to right click anywhere in the request and send it to the Jaeles endpoint, and then go to the terminal where we have the server. So okay, it has sent the request. So it is working right now. There is a minor bug, I'll tell you about that. So see, so now it has first different parameters. So the here, as you can see in the path, it has appended the payload. So that means my signature have not only the query in the generator, request generator, it also has the path in request generator. So I'll show you that signature also. So let's suppose, so this has already been proved that it is vulnerable because we have detected one URL where, which means the URL with the payload. This is the payload in URL, and it has detected it as true positive. So just if I open this URL, I can see that it's vulnerable to SSTI. So this is the value. It has multiplied this. So if you decode this payload, you can see in clear, I mean, in clear text, like, what is the exact payload URL decoder. Or else you can also check the signature file. I'll show you. Let's first decode it. So now it has a logic like multiply 3 into 31337. I have given this number because if suppose I give 3 multiply by 3, the output is 9. So it is possible that in the response 9 digit can like it can exist, right? So that's why it will give me false positive. So to avoid false positive, I have given this long number. So there will be there will be no chances of false positive in this case, right? So for that reason, if I access this, I got that it's vulnerable, right? It has given me the output. So basically, now we will see the signature, like through which what means what we used for scanning. I'll cancel this. I don't want to scan anymore because I already found the vulnerability, right? So if I cat the file, that is ssti.yaml file, so here you can see I have, as shown before, I have injected different types of payload, the SSTI payloads. You can collect more payloads if you have, and you can place it over here. Then I have generated request, and in this I am fuzzing the query parameters. I'm fuzzing the path, and then I am fuzzing the body parameters, and then the cookie values also. I'm trying to inject the payload in cookies. And then if the string response is a simple string search, and in the response, if it finds this value, that is 3 into this, the multiplication of this two digits, two numbers, the output is this. If it finds this in the output, then it detects that as a true positive alert. And then it is again the same string count response. It is the same. If you will remove all this, and if you will only keep this one also, it will detect it. And the next one is I'm generating another request, and that will be the URL encoded request. So here I will directly pass these parameters, but here again I will encode this URL. I'll do a URL encoding, and I will pass it to all the query parameters, body, path, and cookie values. So if the response have results of the template code above, then that is the comment. So the detection is again the same detection. So this way you can fuzz each and every part of a request. The vulnerability can always exist in parameters, it can exist in path, it can exist in headers. You never know, right? So that is the advantage of fuzzing. It is almost impossible to do this manually, correct? So now we have covered all these points. So you know like how we can integrate this with Bob Suite, and we can scan all the URLs. So here in lab, Sugar Lab, I have tried only on one URL, but you can try on multiple URLs. And then we will see how we can generate report of the vulnerabilities which were found during the scan. So for that reason, you have to just enter Jaeles space report, and this will generate a report. And see, it has generated a report in this particular directory. Just go to that directory, open then out directory, and then if you will open this HTML file browser. So let's see. Okay, so we tested for a template injection, and before that, I also tested for LFI. So this was on Portswigger Academy.net, websecurityacademy.net, and it shows us that the uh, report of all the vulnerabilities which were found. So if you check the LFI results, you see it shows what was the request, actual request, what was the payload. The payload was slash etc slash passwd, and then it was able to fetch passwd file. Same way, if you will check this response for template injection, so you need to search in response. Actually, it will tell you this was grabbed, this was found in the response. This is the detection string. So if I zoom it, so detection string, this was found, so that's why detected. So if you want to see the response where it was reflecting, so here it was reflecting in the response. So this way you can fuzz different vulnerabilities. So for example, I can tell you more about it. Like I'll let me open my repo. So this is a person. This is actually my friend. Uh, his name is Gocha Okradze. So actually, he also have his own signatures and he have made it public. So you can clone his repository from Google GitHub, and you can use all these signatures. And I would suggest whenever you are creating or testing the signature for first time, you always test it on a lab and then try it on a live website, because unnecessarily you will have to wait if suppose that signature is not working properly and it does not detect the vulnerability, then your time will be wasted. So it's better to test it on a lab and then test it on a live website once you are sure that it works, it always work. So it depends on your payload, what you inject, where you inject, uh, and the detection mechanism, like how you detect it. So otherwise, if your detection is not proper, then you will get a lot of false positives. So you can clone this repo and you can check the signatures. And one more point I want to add, if you go to jail signature, so it will tell you exactly like how to create your own signature. Like this is the official document, go to this page and then refer the document, like what all parameters we have, what all variables we have, like these are the variables which we can use in our signature. Then these are the detection techniques, like you will see a lot of examples. So you have to research on it, and then the generator, the request which we generate. So what are the different types of requests we can generate? And then you can read the usage. It is I have covered almost most of the things from this. I hope yeah you got the use of this tool. You understood like how this tool can be used. It can be basically it can be used for CV identifying CVs. It can be used for fuzzing different types of vulnerabilities, and it will be a great help in your bug bounty journey. Thank you for watching my video.